Hi, my name is Ben Hutton. It's a privilege to speak to you here at ASC 2021 today. I've been working on the JSON schema specification for a number of years, and I'm currently the specification or project lead. Maybe you're experienced in using JSON schema, or here to learn about it for the first time. I'll be delving deep in some occasions, so if this is your first experience of JSON schema, don't be surprised if some parts seem a little puzzling. And that's okay, you're in good company. You're still going to learn several fundamentals and principles of JSON schema that when you apply them to your own work will make you seem like seasoned JSON schema authors. If you are here to learn about a JSON schema vocabulary, I apologize, but it wouldn't fit in today's talk. Myself or someone else in the community would be more than happy to help guide you, and watch out for articles on the JSON schema blog. Today, I'm mostly going to walk you through a series of questions and answers from Stack Overflow, modified to focus on the key points, which I hope will enable you to find JSON schema easier to grasp than you did yesterday. We'll explore the fundamental model of JSON schema and the implications of being constraints-based. We'll realize that subschemas actually make the mental model, testing, and construction of schemas easier than you imagined. You'll see the 3 A's of JSON schema: applicability, assertion, and annotation all play a role in the validation process model. You'll discover that URIs and URLs are very similar but different, and the impact for JSON schema. Finally, you'll hopefully realize that relative URI resolution doesn't have to be confusing, and that you probably already know how it works in the most common cases already. But first, let's step back. Who uses JSON schema? A few well-known organizations use JSON schema, and now with OpenAPI 3.1 fully supporting JSON schema for payload validation, a lot more is going to happen in the near future. Going back to basics, what exactly is a JSON schema again? JSON schema is a set of keywords or a vocabulary that allows you to validate JSON data. It's an Internet Engineering Task Force personal draft, meaning it's operated by individuals rather than by the IETF themselves. A JSON schema is JSON itself. And JSON schema is a JSON which must be a Boolean or an object. Now, let's unpack that last one a little. Booleans as JSON schemas result in a pass or fail assertion, regardless of the data. True is equivalent to an empty object, which expresses no constraints. False is equivalent to not an empty object, where not inverts the subschema values assertion, which we know to be true. This is the simplest demonstration that JSON schema validation is permissive and constraints-based. Let's take a look at our first real example. oneOf not validating correctly. Let's look at this schema and instance and see if you can figure out the validation result. We may look at the schema and see if the object has the A key defined and any value is allowed. So this should pass validation, but it fails. The oneOf keyword expects that only one of its subschemas in the array value should pass validation. Is the second schema passing validation? Yes, it is. There's nothing in the second subschema to prevent the data defined in the example instance. As a result, the two subschemas are not mutually exclusive, and the required assertion for all of fails. JSON schema is permissive. Let's look at a more involved example. The items of the metric groups array should be an object that has either a property named metrics group 1 or metrics group 2. The poster correctly identified the issue. Both of the metrics groups arrays seem to be valid against both of the subschemas. The poster has a clear understanding of how subschemas work, and the resulting assertions are combined using oneOf. What they have missed is the schemas must be mutually exclusive in terms of what they allow. With our looking at constraints hat on, you might notice that the properties of each subschema are unconstrained. Preventing additional properties to those defined in the properties keyword should be all that's needed to fix these subschemas, making them mutually exclusive. Okay, so let's go ahead and add additional properties false to each of the subschemas. Why does this work? The properties keyword only does validation on the values of the object, not the keys. Properties applies the value schemas based on the matching keys in the instance. Additional properties is also an applicator keyword and applies its value schema to the properties that aren't defined in the properties keyword in our example. Many JSON schema keywords take schemas as their value. These schemas are called subschemas, and they are everywhere. Identifying where they occur helps you mentally break up schemas into manageable chunks, but also enables you to easily debug assumed logic flows. Let's evaluate the next schema and question: how do I reuse JSON schema? Reusing JSON schema is important if you want to follow the dry principle. Don't repeat yourself. In this question, the poster wants to be able to apply the same subschema to an unknown number of objects in the instance data. While the number is unknown, we do know they want to apply the schema to all of the instance objects. Currently, they are only applying the subschema to the value of object 1 on line 7. Fortunately, the solution is quite simple and doesn't require much change. The additional properties keyword actually takes a schema as its value and not just a Boolean. We move the additional properties keyword and change its value to the subschema previously used for object 1. This is because the schema value is applied to all of the values from an object where the keys don't match those defined in properties or pattern properties. As neither of those two keywords are defined in our solution schema, the schema defined under additional properties is applied to every value in the object. Object 1, Object 2, Object 3000. Great. Let's take a look at another example. From JSON schema draft 7, we introduced some conditional applicator keywords in the familiar form of if, then, and else. The poster is excited to hear about these new keywords, but is unsure how to use them. Fortunately, it's to do with subschemas again. All of these keywords take a single subschema as their value. The if subschema is evaluated, and depending on the assertion result, either the then subschema or the else subschema is applied to the same schema instance location. Look at the solution schema at the bottom, lines 9 to 13. This is a subschema. JSON schema keywords can be used again to express further constraints. It's subschemas all the way down, so look out for them. Applicability is key. Everything starts by applying the JSON schema to the instance data. Different keywords can apply subschemas to different parts of the instance, and the keywords in those schemas provide assertions and/or annotations as a result. Let's take a look at the previous question answer again in this new light. How do I use if then else? We found the solution was to use subschemas as the value for the then keyword shown in lines 9 to 13. How does application work here? First, the schema value of if is applied. If is an applicator keyword because it applies a schema to the instance. The assertion result of that application determines another subschema to be applied, while the assertion result from the value schema of if does not directly cause the overall validation to pass or fail. If the assertion result from the if schema value is true, then the then schema value is applied if it exists. Otherwise, the else keyword schema value is applied, again, only if it exists. What happens if default is an object? Nothing. Well, nothing in terms of validation and nothing in terms of altering the instance data. JSON schema implementations should not modify the JSON instance provided, and it should be considered immutable. Default is an annotation-only keyword. Annotations may be collected by the implementation and presented after validation. This allows for further processing, which may include setting default values. URIs are different to URLs, and this does matter in the land of JSON schema. $ID, $F not working in JSON schema. Okay, let's take a simplified version and look closer. There's nothing wrong with the schema itself, but the implementation reports it cannot find the reference schema. This is because URIs may not be network addressable. In fact, you should not even expect to be able to connect to a network or be able to access a file system. Many implementations are able to make HTTP requests, and many do so, but you should not generally rely on this behavior. Instead, check your implementation details. A good implementation will allow you to load in schemas, creating an index using the defined $ID value or a passed URI for resolving its reference. One of the topics I find schema authors struggle with the most is URI resolution, or more accurately, relative URI resolution against a base URI. But that doesn't make such a catchy title. When checking my understanding for this talk, I put out a poll on Twitter to see if other users could work out this particular edge case. The base URI is provided, and a relative URI to resolve against it. Double dots in a path route is not something I've seen, but it is behavior covered by the URI specification. If we have more time, I'll leave some space for you to have a guess, but for now, if you have a gut reaction and you're here live, feel free to share in the chat. Okay, this wasn't designed as a trick question, and I believed the answer was 2. Most believed it was 3, error, which I'd have thought too before reading the URI specification a little closer. But one of the experts in the URI world, Daryl Miller, picked up that it wasn't actually any of the provided options. I'd forgotten that A was part of the domain section of the URI and not the path section. Case closed, right? Then someone else joined. Oliver picked up that query parameters were not preserved. And after some confusion, myself and Daryl agreed. The actual resolved URI was http://a/c/d. Maybe URI resolution isn't as easy as it seems when you consider the edge cases. So I revised my title for this section, but realistically, you probably won't encounter many of the edge cases laid out in the URI specification. So a final title revision, which is a little less catchy, but makes it clear. URI resolution is probably something you already know in most cases. Jason's talk at this conference goes into a little detail about how relative URI resolution is similar to that in HTML. Now let's look at how understanding URI resolution is applied to solve real problems. Error validating using $f. Our error points us to line 18, where a reference is defined, and points to a definition of category list. When using a JSON pointer relative URI fragment, the full path from the root of the resource is required for referencing the definition of category list. Remember, relative URI resolution is relative against the base URI, which is defined by RFC 3986. In this instance, the base URI is found in the value of $ID in the root of the resource, which is also the document root. Let's take a look at a similar but different question. Can a property inside all of $f another all of property? The error message is actually pretty good at indicating as to the problem here. As it says, it cannot resolve the reference against the ID or the base URI. Remember how earlier we talked about subschemas being everywhere? The object starting from line 16 is a subschema, but this time it has defined its own base URI using $ID. The subschema starting at line 6 has done this too. Subschemas that are defined using their own ID value change the base URI, and we define these subschemas as new schema resources in order to differentiate between the whole schema document. The solution here is to define the reference on line 23 as #/properties/foo. You might notice this is the opposite problem to our previous question, but the same understanding allows us to solve both problems. Relative references resolve against the current JSON schema resource, not the document root. Often those are the same, but in this instance, the use of ID has changed the base URI and identified a subschema as an embedded and separate schema resource. Again, the base URI by which relative URI references resolve is something defined by another specification, RFC 3986. While we can't go into all the specification detail, I want to show you the single diagram that took me the longest to understand. One of the hardest aspects to understand about resolving relative URIs is how the base URI is determined. The JSON schema specification almost seems to omit this explanation, other than pointing to RFC 3986. That's the URI specification for the rest of us. Getting to grips and really understanding this graphic from section 5.1, establishing a base URI, really unlocks my understanding. The graphic is an onion layer of establishment protocols, starting at the inside and stepping out a layer each time the base URI isn't established. At the innermost layer, we start with the relative reference we want to resolve. The numbers associated with each layer are references to further sections in the specification which provide more details. I'll leave that to read on your own time. To start, 5.1.1. We need to look for the base URI embedded in the content itself. For JSON schema, that's the closest $ID value. Next, 5.1.2, encapsulating entity. My interpretation of this is the base URI defined by an OpenAPI or AsyncAPI specification document, or similar. 5.1.3 Retrieval 5.1.3 Retrieval URI. This is usually going to be a URL which you have used to make an HTTP request, but it could also be a file protocol URI if an implementation has been told to use files in a given folder and it has loaded them in with the knowledge of their original location on disk in a folder structure. 5.1.4 Finally, some sort of a default base URI, application defined. If a base URI isn't determined with any of the previous steps, define something. This is likely to aid the use of existing relative URI resolution libraries because you don't generally want to be writing those yourself. As we've discovered, a URI resolution is hard, and there are edge cases. But in most cases, you probably already know what to expect, especially if you recognize the similarities with this behavior between HTML and anchors. My hope is that we've connected a few of the dots towards a fuller understanding of JSON schema. Anything not constrained is allowed by default. Add constraints. Subschemas are everywhere, and recognizing them is key. Know what keywords take subschemas as values. Applicability is the start of the JSON schema validation processing model, resulting in assertions helped along the way by annotations. Knowing which is which makes reading schemas easier. It really matters that URIs and URLs are different in the context of JSON schema. Understanding that URIs are not necessarily network addressable helps you remember the requirements to register schema identifiers. URI resolution is mostly quite simple once you know the base URI. And really, most web developers who've worked with HTML, you kind of already know how relative URI resolution works via URLs and anchors. Finally, remember, JSON schema can be Booleans, and this makes debugging simple. Test your validation pathways using Booleans and as subschemas, and you'll find debugging your next 1,000-line schema a breeze. But truthfully, there's so much more to learn. Should you want to really master JSON schema. So where do I go to learn more? Get involved and contribute to the community, or keep up with developments? We provide 2 layers of learning resources, and we're looking to unify those in the future. The easiest way to try JSON schema today is to write it in Visual Studio Code and paste it into one of the web-based playgrounds. If you need help, we monitor the Stack Overflow JSON schema tag. And if you want to get involved with our community, join our Slack or follow on Twitter. Elevating the community and the organization is a priority right now, and you can track these developments on our community repo, discussions, and issues. We've come a long way, but we still have a way to go, and more exciting things are in the works. So thank you all, previous and current team, contributors and community, and our implementation developers. And thank you to our sponsors via our Open Collective, Retool, AsyncAPI Initiative, Stoplight, Airbnb, and API Deck. If you're interested in sponsoring JSON Schema, please visit our Open Collective. We are largely unfunded and would love to be able to build more. Thank you for having me here at ASC 2021. My name is Ben Hutton, and thank you for listening. I'll now be here to take any questions. Hi, everybody. I hope that was useful. Thank you, Kim. Yeah, Vladimir, I'm not entirely sure what you meant by your question in relation to the what working group URL standard is being suitable for JSON Schema UI resolution. Could you expand on that, maybe? Otherwise, I'm happy to take any other questions via chat or the Q&A section. Doesn't look like we have any other questions coming in, but I'll give it a couple of minutes in case any of you are still sort of processing that. I'm aware it's quite a lot to delve into in such a short space of time. But yeah, if you do have any questions, feel free to reach out to me on the JSON Schema Slack, or I'm also available on Twitter. Yeah, thank you for listening, and let me know if you have any questions or feedback.